Hello all, this is Anish Raj from Savita Engineering College from the Department of Artificial Intelligence and Data Science. And my final year project is BLOOD SCAN AI, which is blood group detection via fingerprint analysis. And our goal is to implement blood scan AI with the help of modern AI technologies like efficient net deep learning architecture. It is used to classify the blood group such as all the eight blood groups and give a confidence score. And coming to the existing system is a traditional based one, and it takes a lot of time to scan the images and perform such as identify the ABO and RH antigens, quality control, irrigation, and documentation in the medical records. This process is highly resource intensive because it consumes a lot of expertise, infrastructure, and time. Medical professionals must carefully collect the blood samples, and in the laboratories the result will be confirmed. So in order to minimize that, we have implemented with the software basis with the help of efficient and deep learning model. And the proposed system is it introduces AI powered technology which gives the blood group based on confidence score with the help of biometric pattern recognition. And the built model predicts approximately 27% confidence per blood group, which means representing 93% over all the previous models. And it can be done within 10 to 15 seconds. And the advantages is it is non-invasive, and instantly we can get the results, and it's highly accessible since it is software, and it's a cost-effective solution compared to modern methods. Yeah, and the scope of the project is, as I said, to build a basic AI model to predict blood groups, and it can be uploaded in different formats such as PNG, JPG, JPEG, and WebP format. And the system encompasses a real-time finger analysis with sub-3 processing quantitative probability distribution method. And the data is performed in the MongoDB database for storing the blood group and scanning fingerprints, that kind of metrics. And the modules used here are, first of all, we have used a AI model integration module, then image processing module, then a database side, and followed by that we have used a API module for front-end interface, and finally the deployment model. And coming to the software requirements, for the backend side we have used Python 3.11 fast API. It is the core part of the project, and these libraries are inbuilt in Python since I don't need to explain them. And for the front end side, we have used Node.js, React, Tailwind, and Station UI components. And MongoDB we have used for the database side, and we developed it using VS Code and Git Postman for API testing. Hardware requirements are basic requirements. You can refer to it. It can be done in any hardware since we have not given any hardware constraint. It can even process in low-end PCs and low-end laptops, mobile, etc. And this is a system architecture. We are first of all user interact with the data. They will upload the fingerprint image, and it will extract the feature from it, and the blood group prediction via will be visualized at the final end part. And it's a class diagram, use case diagram, and it's module descriptions. And module description is an important one. This module for the AI model integration module, this model manages I actually mentioned efficient net B0 deep learning based model. It's a 19-layer CNN model which is about size of 42.12 MB, and the model handles pre-processing the fingerprint images, which is 64 into 64 RGB normalization, and it can classify all the 8 blood groups, and image processing module handles all the image processing operations. Since we need to pre-process the model, right? So we are performing the given the image processing module. It can be done in any form such as PNG, JPEG, and WebP format. Each size is up to 10 MB, and its model specific resizing to 64 to 64 via bicubic interpolation. And database model we have used the basic thread operations along with 8 blood groups. And API we have used fast API and RESTful API to for the web-based processing, and it's deployed in using AWS, Azure, and any platforms. And this algorithm here. First of all, we take the input, then we validate the image, which is resizing them, and load the image and convert into grayscale image, and we will resize it, and with the help of numpy arrays it can be normalized by dividing it with 255, since the RGB value ranges from 0 to 255, so it will be easier for the model to read. And in order to convert into the RGB module, we can use the stack with into 3 this calculation for converting to RGB channel. And we are adding batch dimension at every step, since with the help of batch dimension only we can get the image information clearly. Without it, it cannot be possible. And for the output side, we have used this output layer 1,64. It's a batch dimension and it's a conversion layer. And the UI looks like this, where the user will be able to upload the image like this. You can give the image here, and after that it will show the confidence score like this based on the image samples. It will look like this, and yeah, it's this is the output format. And yeah, it's we should not jump to the conclusion. Let's get into the coding part. This is the coding part here. For the coding side, we have imported the necessary libraries, and we have initialized the fast API here with the title and description, and along with the version. And for the middleware side, we have used this cell. And to create a MongoDB connection, we have used this string, this part of the code. And for thread pool, to model, because of the model to interfer, we have used it. And we can adjust the number of workers, depends on the need. Here we are mapping the blood groups, the eight groups, and these are global variables. We can use it later. And this block of code is for loading the model. Yeah, we have loaded the model here. Models group dot is in H5 format with the help of exception handling. And we are loading the backup model here. If the primary model fails, the backup model will perform the calculation. And followed by that, we have implemented the image conversion techniques. Here we are converting into grayscale, and here which resizing into 64 size. And I said earlier, it's used to convert into RGB 3 channels with the help of this computation. And we are batch dimensioning here, and we are returning the image, and we are predicting the blood group with this block. Yeah, it's a function. And if the primary model is using it, we are predicting is using the primary model. And if it fails, we are using it with the backup model. This block of code is for the backup model from here to here, and we will get the predictions for the chosen model. It will be in the form of classes, since we are using softmax layer for it. And it's for the probability distribution, for which class, how many the probabilities, confidence score probabilities on the model used. And this API is to predict the blood group from the fingerprint image. We have connected it using MongoDB. and these are not the necessary parts. And store it in the database. Yeah, if this is a necessary part. That's it for the thing. And yeah, it's a final part. And with the help of the above algorithms, we have successfully implemented a blood group detection via fingerprints software. And yeah, I conclude saying that with the help of the team and faculty members and mentors and project guide, it will not be possible. Um, thank you everyone for it. Thank you for my team. Thank you for my project coordinators, and that's all.